All right, guys, so we're continuing the note sheet from yesterday. You do have note sheets and calculators, yes? Still need the calculators. Okay. Yep, I still had you down with 9. Okay, turning it back in. Okay. All right, guys. So what we finished with yesterday was our rational zeros. Our plus or minus P over Q, where P is the factors of the constant term, in this case 20, and Q is the factors of the leading coefficient, the number in front of our variable with the biggest exponent, which was 1. And we got these listed out. Now, the pure mathematical way, if we were tackling this with just the rational zeros, we would look at these here. So we have positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, and positive negative 20. These are possible rational zeros. So if a solution is a rational number, it can be written as a fraction, it is listed here. So I wouldn't write this first step, but what we could do is we could start with, well, 1, because 1 is one of the possible rational zeros, and we'll go through the synthetic division steps. Because 1 times 1 is 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is, well, negative 7. 11 plus negative 7 is positive 4. 1 times 4 is 4, and 20 plus 4 is 24, telling me that the remainder for this here is 24. And if it is a solution, the remainder should be what? 0. Okay, well, since we didn't get a remainder of 0, it means it's not a solution. We remove it from the list. So positive 1 is out. And it's if one of the solutions does not work at one of the synthetic divisions, it won't work later. So since positive 1's out, we're going to move to negative 1 and try this again. Negative 1 times 1 is negative 1. Negative 8 plus negative 1 is negative 9. So from our possible rational zeros. So when we list the possible rational zeros, our P over Q, it is positive or negative. We do have both cases. So we get negative 9. Negative 1 times negative 9 will be positive 9. 11 plus 9 is 20. Negative 1 times 20 is negative 20, and 20 plus negative 20 is indeed 0. So we can say negative 1 is indeed a solution. Questions on this so far? Is there anything that's saying that negative 1 can't be a solution again? No, so we could try negative 1 again. If it doesn't work, we move on to 2, negative 2, 5, 4, negative 4, 5, negative 5, 10, negative 10, 20, negative 20. It could also be that this is the only rational solution. That's a whole lot of synthetic divisions just to see if negative 1 works again, because we would bring the 1 down. Negative 1 times 1 is negative 1. Negative 9 plus negative 1 is negative 10. Negative 1 times negative 10 is 10, giving us 30. Okay? Pretty much all that showed us is that negative 1 only worked once. Well, from there we can move on to, say, 2. Negative 2, 4, negative 4, and do the rest of these. Or we can graph it. is we can hit y equals x cubed minus 8x squared plus 11x plus 20. And if I graph it, again, when it crosses the x-axis, that's the value of x that will make the y value be 0, make the equation equal 0. As we can see here, -1 is a solution. It does make the function equal 0. Another one we have is 4, and we have one more at 5. So if we try this with 4, we should get a remainder of 0. 4 times 1 is 4. -9 plus 4 is -5. 4 times -5 is indeed -20, and 20 plus -20 is 0. Now at this point here, we can fill the variables back in. X minus 5 is 0. We add 5 to both sides, and it does verify that 5 is our third answer. Questions on this here? So realistically for this one here, we could have what? Just graphed this and gotten all the answers. Because it gave them to us all by graphing, because they were all integer solutions. They were all integer numbers. Questions on how we found the rational zeros and found our 3 solutions? All right. Let's look at this one here. X cubed plus x squared minus 14x minus 24. The main thing we want to look at is finding the rational zeros. Now with our rational zeros, we need the values of p and q. P is the factors of the constant term, our number without a variable. And the number without a variable in this case is 24. We're not so much focused on the negative. We're just looking at factors at 24, because when we find the rational zeros, they're always going to be positive, negative. So we're not so much concerned about the sign with 24. Now, one of the sets of factors with 24 as well, 1 and 24. 2 is also a factor. It'd be 2 and 12. 3 is a factor. We have 3 and 8. And then 4 and 6. We're just looking for all the numbers that multiply together to give us 24. Q is the factors of the leading coefficient, the number in front of the variable with the biggest exponent. In our case, it is, well, they didn't write it, so it's understood to be what? 1. Plus or minus P over Q. So, in front of each one, we'll put a plus or minus. Now, the way I work these here is I take every factor of P and divide it by the first factor of Q. And once I finish doing that, then I'll move and do the same thing with the second factor. But since there's only 1, we're just dividing everything by 1. And 1 divided by 1 is 1. 2 divided by 1 is, well, 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 8 divided by 1 is 8. 12 divided by 1 is 12. And 24 divided by 1 is 24. And as you do these here, I would simplify them down. If you need to, just have that 30xs, the yellow calculator. The yellow calculator does fractions, and simplifying fractions a lot easier and a lot faster than that graphing calculator. Because the graphing calculator, to get a fraction, we got to go alpha y equals enter every single time. The nice thing with the yellow calculator is we hit the fraction button, it'll let us do that there. Now at this point here, I would move on to the next factor of q. So if we had a 2 was also a factor of q, we would then divide every factor of p by 2 and move through the factors of q. But since 1's the only factor of q, that tells us these here, 1, 2, 3, 4, 6, 8, 12, 24, positive and negative, are the possible rational zeros. And if we had tackled this the pure mathematical way, we'd set up our synthetic division. We'd go 1 for x cubed, 1 for x squared, negative 14 for x, negative 24. Bring down the first term, and then we can start with positive 1. And if that gets us a remainder of 0, it's a solution. If it doesn't, we go on to negative 1. And if that works, it's a solution. If it doesn't, then we go to 2, negative 2, 3, negative 3, 4, negative 4, all the way through. Or we can grab the graphing calculator and let it try to give us some help. So what we want to type in is that equation. So x to the third, our x caret 3 plus x squared minus 14x minus 24. Because once we get it typed in, it's going to give us this graph. And we're looking for zeros. We're looking for where it's going to cross that x-axis. And we do see a few places. We see negative 3, negative 2, and 4. Which is actually very helpful because it tells us, one, either one of the ones worked. So that would have given us an error on both cases. So the first one that would have worked would be negative 3. Negative 2 and 4. Come on. Yep. And that's it. We haven't gotten there, but especially in 4.6, this will actually tell us that's all the solution. That's it. Because if we did the synthetic division to make sure, so if we did negative 3 times 1 is negative 3. 1 plus negative 3 is negative 2. Negative 3 times negative 2 is positive 6. Negative 14 plus 6 is negative 8. Negative 3 times negative 8 is positive 24. And negative 24 plus 24 is indeed 0. We can do it again with negative 2. Negative 2 times 1 is negative 2. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 4 is positive 8. And negative 8 plus 8 is 0. Leaving us with x minus 4 is our last expression. We fill the variables back in. Negative 4 is our term without x. 1 is our term with x. And if we solve this here by adding 4 to both sides, tells us x is indeed equal to 4, which the graphing calculator already told us. Questions on this here? We feel kind of comfortable so far, at least with finding rational zeros and solving these here. Because for the most part here, the graphing calculator told us everything, didn't it? Okay. For space-wise, we're going to skip that one. We're going to look at this one here. We want to find all the real zeros of this polynomial. Well, at this point, why do we even need to do the rational zeros? So let's just graph it. So I would definitely make sure you're graphing this one. 10x to the fourth minus 11x to the third minus 42x squared plus 7x plus 12. We're able to graph it. So y equals, so x is the button right next to alpha. Yep. And once you get it, hit graph. Yep. Got to hit y equals first. And make sure you're able to get this graph, get it typed in and graphed. Everybody get it typed in? Because once we get it typed in and we hit graph, we see that we have these intersections here, yes? And again, we're looking for where it crosses the, or what value of x is going to make the y value be 0. Well, as we see here, all the values are within, because one's probably, well, they're all less than -2, or greater than -2, less than 4. So they're all in that range. And if we look at the table, it's not telling me any value of x that would make this be 0. We don't see any zeros in the y spot. Okay. Now for these here, this is definitely where finding these rational zeros is going to be important. Now, when you list these here in the note sheets, list these rational zeros, I would put it above example 4 because there's not a whole lot of space in example 4. So, we need to find these rational zeros. Now, P is the factors of the constant term. And our constant term in this case is what? 12, yes? So the factors of 12, we have 1 and 12, 2 and 6, 3 and 4. Those are the factors of 12. Now our factors of Q is factors of the leading coefficient. Factors of the number in front of the variable with the biggest exponent. Yes. That's the factors of 10, which would be 1 and 10, 2 and 5. Questions on how we found the factors of P and the factors of Q? So what I start off with is the first factor of Q and divide it by every factor of P. So the first one we're going to have is 1 over 1. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by our 1 is 3. 4 over 1 is 4. 6 over 1 is 6. And 12 divided by 1 is 12. So all we did was took all those factors of P and divided by 1. Because we really had 1 over 1, which is just 1. 2 over 1 is 2. 3 over 1 is 3. 4 over 1 is 4. 6 over 1, 12 over 1. We good with this so far? Now what I do is I move on to 2. And I do it this way to make sure we get each of the factors. If a factor shows up more than once, we don't write it more than once. So the next one we're going to have is 1 over 2. Well, 1 does not divide by 2. It doesn't simplify, it's just 1/2. Next one we have is 2 over 2. Well, what is 2 over 2? 1, do we have it? Yeah, we're not going to list it again. Next one we have is 3 over 2. 3 over 2 doesn't reduce, it's just 3/2. From there we have 4 over 2. Well, what's 4 divided by 2? 2. Is it listed? Okay, we're not going to list it again. Next one, 6 over 2. 3. That's already there. And lastly, 12 over 2 is, it's already listed. So all we really added with 2 was 3/2 and 1/2. Now we're going to move on to 5. Well, 1 over 5 is 1/5. Then we do 2 over 5, which would be 2/5. 3 over 5, 3/5. 4 over 5, 4/5. 6 over 5, 6/5. And lastly, 12 over 5, 12/5. And last but not least, we need to do this also with 10. Now, 1 over 10 is going to be there because 1 and 10 aren't going to reduce. 1's always going to be listed in the top number every single time. But now we can move on to the next one, which would be 2 over 10. Well, that's going to be 1/5. We already had it listed. Next one we have is 3 over 10, which would be 3/10. 4 over 10 is going to reduce to 2/5. 6 over 10 reduces to 3/5, and 12 over 10 reduces to 6/5. If you're not sure about them, just use the calculator. It will tell you the reduced form every single time. But getting rid of, making sure to reduce it gets rid of those extra factors because there's enough of them listed as it is, yes? Now the question is, why did we need these? Well, again, if we have rational zeros, and we should get at least 2, we want to find n minus 2 solutions, where n is the degree, so 4 minus 2, we need at least 2. If 2 of these are zeros, that's great. If we get 3, that's better. If we get all 4, that's the best possible outcome. Now, looking at these solutions, which ones can I get rid of already? Well, we've looked at the graph already, yes? Did it cross at 1 or -1? How about 2 or -2? No, how about 3 or -3? 4, -4, 6, -6, 12? Because we saw these for sure. And I can grab the calculator, say second table. Well, when x is -12, it's definitely not 0. And let's see, when x is 12, it's also not 0. One, two, three, four, five, 6. We got rid of 12 possible zeros just from the graph, just from looking at the graph. So now we're looking at these other fractional answers. And we can use them and the graph to figure out which ones we have. So one of them is just looking at where would they land on the graph in terms of our possible solutions. Now the other possibility, and the other way that we can do this, is I want you to hit second, so hit the blue button, trace, the button right next to graph. Second, trace. Do you all see this list here? What is the first option that we have? Hit enter with a value. Select it. What is it saying there? X equals. As long as the number that we plug in for X is inside the window, inside the X values that is listed here. So in this case, -10 to 10. It will tell us the value. So the first irrational value that we have listed is what? 1/2? 1 over 2, yes? So if I type that in next to X, what you're telling the calculator is, hey, tell me what the value of Y is when X is 1/2. So when X is 1/2, it tells us the Y value, the output value is 4.25. What do we want that Y value to be? 0, so 1/2 didn't work, yes? What's the next one we can try? 3/2. So the nice thing is, and this is interesting, I found this out today, once we do second trace value the first time, we don't have to do it again. I can say 3 divided by 2. It'll let me try it again. 3/2 is -58.5. Well, because it is positive negative, yes? Because 1/2 didn't work, we could also try -1/2, yes? And when Y or X is -1/2, the Y value is 0. So that tells me X is equal to -1/2. I do have one of my solutions. So -1/2 worked. We didn't try -3/2 yet. So -3 divided by 2. Negative 3/2 gives us a y value of negative 5.25. Now I would just start going down that list. We can try 1/5. 1/5 did not give me a y value 0. Negative 1/5, negative 1 divided by 5. Well, that's out. And then what can we do next? 2/5. And then negative 2/5. 3/5. Well, 3/5 actually gave us a y value of 0. So that works. So I would definitely list 3/5. We can check negative 3/5. That doesn't work. 4/5 doesn't work. Negative 4/5 does not work. Our next one after that is 6/5. Negative 6/5. 12/5. Negative 12/5. 1/10. Negative 1/10. 3/10. And negative 3/10. So really, we went through, and I just went through all of them. I went through the rest of them pretty quickly. But it told me the two rational solutions are negative 1/2 and 3/5. This gives us a way to find those values, especially if they're not directly given to us. Now, there are two more solutions, but to find those, we're going to have to use synthetic division to get it down to a quadratic. And once we get it to a quadratic, we can solve the quadratic equation. So the first one we're using in that cubby is negative 1/2. So we're going to multiply and add. Negative 1/2 times 10 is going to be negative 5. Negative 11 plus negative 5 is going to be negative 16. Negative 16 times negative 1/2. Negative times a negative is positive. 16 times 1/2, 16 divided by 2 is 8. Negative 42 plus 8 is going to be negative 36. Okay, that's why. Negative 36 times negative 1/2, negative and negative make it positive. And half of 36 is 18. Nope. Because that should not be 36. That should be 34. Negative 42 plus 8 is negative 34. Negative 1/2 times negative 34 should be positive 17. 7 plus 17 is going to be positive 24. Negative 1/2 times 24 is negative 12. And negative 12 plus 12 plus negative 12 is indeed 0. And it worked, and we knew it worked because the graphing calculator helped us find it. 3/5. And again, I will say this time and time again, you do not have to do this in your head. You can do this on the calculator. That is perfectly fine. Because the first thing we're doing is 3/5 times 10. 3/5 times 10 gives me 6. Negative 16 plus 6 is negative 10. 3/5 times negative 10 is actually negative 6. Negative 34 plus negative 6 is negative 40. Three-fifths times negative 40 is negative 24. And 24 plus negative 24 is indeed 0. So the whole goal of this was to get that all the way to a quadratic. Now we had a lot of extra values to get there, but it did get us down to a quadratic. Now unfortunately we can't take it any further than this. So we are going to have to put the values of x back in and solve. So we have 10x squared minus 10x minus 40 is equal to 0. Now at this point here, you might be running out of room, so you might need to jump up and use the space in the problem above it to find it if you need. Because at this point here, our main two methods for solving is completing the square and the quadratic formula. Space-wise, I would just use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, this is matching back up with our ax squared plus bx plus c. A in our case is 10. So its two spots would be 10. B is negative 10. And C is going to be negative 40. Now our negative 10 out front, the negative and negative would make a positive. At the bottom of the fraction, we have 2 times 10, and 2 times 10 is 20. Now at this point here, we do need to figure out everything inside the radical. I wouldn't put the radical. But I would put the negative 10 squared minus 4 times 10 times negative 40. I would put everything else. I'd put everything inside that radical. And it tells us it's 1,700. Questions on this so far? Now the 1,700 is positive, so I don't have to worry about imaginary numbers. But it's telling us it's 41.23105. So we'll have to do it a little bit by hand. But I will tell you this, it is 10 square root of 17, because 100, 10 times 10, because 100 times 17 is 1,700. So the 100 would simplify to 10. Because really what we're saying is that we have 17 times 100, or the square root of 17 times the square root of 100. Square root of 100 is 10. Can't take square root of 17, so it's 10 squared to 17. Questions on this here? We can say we're done as long as the two numbers on top do not have a greatest common factor with the number on bottom. So do 10, 10, and 20 have a greatest common factor? 10, yes. Because if I factor out the 10 on top, the first one is just going to be 1. The 10 in front of the square root of 17 would also reduce to 1. They'd both be 1. So we'd have 1 in the first plus or minus 1 times the square root of 17, which is just square root of 17. And if we factor the 10 on bottom, we're left with 2. So our other two solution is 1 plus or minus square root of 17 over 2. Won't get something as complicated as this on the test, but there are going to be some you're going to have to do the synthetic division for. Might not be a whole lot where you have to use the rational numbers, but we do see how using the rational numbers did give us enough of a head start to be able to solve the rest of this. That's what the rational numbers, these rational zeros, this theorem is helpful with, because it gives us enough solutions to be able to solve the rest. Questions on this here? Let's look at the next one. 6x to the fourth minus 11x cubed minus 16x squared plus 2x plus 4. if we wanted to, we can start off by graphing this. And it's, again, if you notice, a lot of this solving is based around graphing, being able to plug these in. Because we can type this in, 6x to the fourth minus 11x to the third minus 16x squared plus 2x plus 4. So we plug the whole thing in and graph it. Now if we notice again, we do not have a nice integer solution. So just like the last one, it might be good to find our rational zeros, our plus or minus p over q. Now the p in this case, the constant term is 4. And the factors of 4 is 1 and 4, and then 2 and 2. We don't list any repeated factor more than once. Factors of 6 are 1 and 6 or 2 and 3. Now we can take our plus and minus p over q. So p is the factors of the constant term, our number without a variable. So what numbers multiply together to give us 4? 1 and 4, and 2 and 2. Since 2 shows up twice, we're only going to list it once. Q is the factors of the leading coefficient, the number in front of our variable with the biggest exponent. So 1 and 6, 2 and 3. Make sense? Yes. And now I take every factor of p and divide it by each factor of q individually. Now the first one we're going to start off with is 1. So we're going to divide 1, 2, and 4 by 1. Well, that's just going to be plus or minus 1, plus or minus 2, plus or minus 4. That just gives us those numbers back. Now we're going to do the same thing with 2. So we'd have 1 divided by 2. 1 over 2 is 1/2. 2 divided by 2 is 1. It's already there. 4 divided by 2 is 2. They have a common factor. Then we're going to move on to 3. So we have plus or minus 1/3, 2/3, and 4/3. And lastly, we're going to do the same thing with 6. So we'd have 1 over 6, which is 1/6. 2 over 6 would reduce to 1/3. It's already listed. And lastly, 4 over 6 would reduce to 2/3. It's already listed. So these are our rational zeros. Questions on finding these here. And as we saw in the graph already, I can throw 1, 2, 4 out. Because if 1, 2, or 4 was a rational zero, was a solution for this here, the graphing calculator would have told us it already, and it would have been nice, and we wouldn't have to necessarily list these out. However, we can come second, trace, value. And I would tell it to find the value of the first value of x that we have left, 1/2. And C, does it give me a y value of 0? It does. So I know x equals 1/2. Positive 1/2 is a solution. And because it crosses the graph, we know it's going to show up an odd number of times if it is a solution repeated. The next we can go is negative 1/2. It does not give me a y value of 0. So I'll move on to positive 1/3. Negative 1/3. Positive 2/3. Negative 2/3. Does indeed give me a y value of 0. Then we can move on to 4/3, negative 4/3, 1/6, and lastly, negative 1/6. So really we figured out the only two rational solutions that we have for this here is 1/2 and negative 2/3. Yes? Now we're going to start our synthetic division process with 1/2. So 6, negative 11, negative 16, 2, 4. We're going to bring down the 6. 1/2 times 6 is 3. Negative 11 plus 3 is negative 8. 1/2 times negative 8 is negative 4. Negative 16 plus negative 4 is negative 20. 1/2 times negative 20 is negative 10. 2 plus negative 10 would be negative 8. And 1/2 of negative 8 is negative 4, which does give us 0, which is what we wanted. Now we're going to do the same thing with negative 2/3. Negative 2/3 times 6 is going to be negative 4. Negative 8 plus negative 4 is negative 12. Negative 2/3 times negative 12, the negative and negative make a positive. And then 4, 8. Negative 12 plus 8 is, negative 20 plus 8 is negative 12. Y'all can go once we finish this problem up because we're almost there. Negative 2/3 times negative 12. The negative and negative would make a positive, and 2/3 times 12 gives us 8, telling us that this is 0. Guys, we're finishing this. We're finishing this problem. So at this point here, we've got to fill the variables back in. Negative 12, the first negative 12 is going to be our constant term, our term without x. The second negative 12 will be our term with x. 6 is our term with x squared. Now at this point here, we're going to have to use our quadratic formula, our negative b, plus or minus the square root of b squared minus 4ac all over 2a. b in our case is this negative 12. We'd fill it in its 2 spots. A is 6, so it goes in its 2 spots, and C is also negative 12. Send the page out. Now at this point here, our negative 12 will be positive 12. On bottom, 2 times 6 is 12. Now at this point here, we would also grab the graph or yellow calculator and tell it to put negative 12 squared minus 4 times 6 times negative 12. And the calculator will tell us that it's 432. Now that does simplify. Interestingly enough, the square root of 432 does reduce to 12 square roots of 3. And this is over 12. Now because there is a greatest common factor of 12, the two 12s on top are going to reduce to 1. And 1 squared is a 3. And the 12 on bottom would also reduce to 1, telling us our last two solutions are 1 plus or minus the square root of 3. Y'all can go to lunch.